Well, we have a little bit of time, so I'm going to show you one way of proving that this is true. And it uses, hand me the blue marker. It doesn't tell you how to discover the formula, but it does tell you how to prove that it's true. And it uses a technique called mathematical induction. Is that a technique that is familiar, or at least do you feel like the name is familiar?
Yes. So I think you prove it for one value, and then you prove that you can scale up that idea to the next value, and then you can do that for infinity.
Okay, yeah, very good. So what mathematical induction for these kind of straightforward problems is we check it at the beginning. So we check, is it true for the first case, for n equals 1? So does 1 equal 1 times 2 times 3 over 6?
Indeed it does, yes.
Yeah, and it's always very important to check that first value, because if you skip that step, you can sometimes prove things that are not true, which is bad. And then this is the interesting part. I'm sorry, I'm writing through the tripod here. So we assume it's true. To n equals some value k. So we assume it's true up to some value like 10 or even 2 or 3. And we can make this assumption because at least we know it's true for one value in the beginning. And then we try to prove it's true for what?
K plus 1.
So in other words, this last step is saying, hey, if it's true up to from the beginning up to some value, then it's true for the next integer value.
Okay.
And then we've made a ladder, and we can just walk up the ladder.
Yes.
Okay, so let's assume it's true up to n equals k, which would just simply mean that up to n equals k, we have this formula that this sum is k times k plus 1 times 2k plus 1 over 6.
Okay.
And now we want to prove that 1 squared plus 2 squared plus 3 squared plus k squared plus k plus 1 squared, does this equal, what do we hope that this ends up equaling?
K plus 1 times k plus 2 times 2k plus 3 over 6.
Over 6, okay. So what do you think our first step in proving this is true is going to be?
Well, it seems like because these two values are so similar, on the left side we can subtract the first one away at some point.
Okay, yeah, that's a good idea. Let's subtract. If this was true, and we know this is true, we're assuming this is true.
Yes.
That should mean that if I subtract, what am I going to get on this side?
K plus 1 squared equals...
Does this equal...
K plus 1 times k plus 2 times 2k minus
2k
plus 3
yeah.
minus k times k plus 1 times 2k plus 1 all over 6.
Yeah, and maybe to make the writing of it simple, maybe I'll just multiply everything by 6 in the beginning, so that this side 6k plus 1. So now I get k plus 1, k plus 2, 2k plus 3, minus k plus 1, 2k plus 1. Okay.
Well, it seems like we could multiply k plus 1 squared out. That's going to be k squared plus 2k plus 1, and then maybe multiply these out and see if we can just simplify them that way.
Yeah, that actually would be one way to go for sure, multiplying out. There is a simplifying step that we can make first, though, just to make our life a little bit easier, sort of simplwer before we multiply.
Well, we can divide by k plus 1 in all the terms.
And we know that's not 0. Why? Why do we know that if we're going to divide, we've got to check it's not 0? Why is k plus 1 not 0?
Well, we proved it for k, and if the lowest k could be was 0, because we start with, or actually the lowest k could be was 1.
Yeah.
So we know k plus 1 is at least 2.
Okay, so we divide out a k plus 1, and that's going to simplify our multiplications out by quite a bit.
Yep.
So now we're trying to prove that 6k plus 1 is this.
Minus that.
Minus that.
So
K times 2k plus 1. Okay.
So
What's this side?
6k plus 6. And then,
And does this equal?
let's see, that's 2k squared.
2k squared.
Plus 7k.
Let's see. No. Oh yeah, sorry. 4 and 3.
Yep.
Plus 7k.
Plus 6.
Plus 6. Ooh, that's
Is promising.
nice.
Okay,
Promising.
so
minus
minus 2k squared
the quantity 2k squared.
plus k. So minus 2k squared minus k.
Yep. So what does this side become?
This 2k squared cancels, and then 7k becomes 6k. And we get what we want.
6k plus 6. And so our question mark becomes a check.
Alright.
So that shows us if we had the formula, we could prove that it's true. And then there's the sort of subtler question of how do I find that formula? Which also actually is not stupendously hard, but not something we could do in a 5-minute video.
Yeah.
Anyway, it's pretty cool. So I wanted to show you sort of both the geometry and the algebra.
Alright, cool.
All right, good job.